All right. So welcome back, students. This lecture we will see about the applications of diodes. So in applications of diodes, we will see how these diodes are being used in various applications for the day-to-day purpose and in the circuits. So in this application, before coming to this, I would like to remind you about the diodes. So when we studied about the diodes, the symbol of this diode was given like this. It has two terminals, one is the anode, the other one is the cathode. So it was known from this operation of diodes that the diodes are able to conduct only when the anodes are kept at the higher terminals and cathodes are maintained in the lower terminals. So that means the current could travel only from anode to cathode. The conduction was possible only from anode to cathode, but not from cathode to anode. So this kind of is called as the forward bias. And in the reverse bias, that is the reverse action of it, that is we will connect the cathode to the higher terminal and the anode to the lower terminal, where the conduction was not possible because of the depletion layer, which could not be depleted when the reverse bias condition takes place. So from the very well understanding of the working of the diodes, we are able to find that the current can only travel through in one direction. So, taking this as an base of understanding, we could now able to think that where these diodes can be used. We earlier we came to know that in the electricity there will be two types of currents. One is alternating currents, and the second one is direct currents. So, preferably we used to say AC circuits and DC circuits, right? In the difference between the AC and DC is nothing but in AC the current is bidirectional and in DC the currents are unidirectional. So it means that in AC the current can travel in both the directions. It keeps alternating its direction. That's why it's named as alternating current. But in direct current the current directions are very same, that is they are always in the same direction. So this can be again explained in a simple way. If we take a conductor, this is the conductor whose terminals are A and B. When this conductor is connected to an AC circuit, that is alternating current circuit, we know that the current would travel from A to B for a certain period, which is IAB, and for other certain period the current will start to travel from B to A like this. This is why it is called as bidirectional condition, and this is happens in the AC circuits, where the graphical representation of the curves of the current, if I take, will be representing it. The first half the current will start from the zero time period and slowly falls to come back to zero, goes to maximum and comes back to zero at a time period of 10 milliseconds. And later the second half cycle the current used to take from the zero again, it changes its direction and goes to the maximum peak and falling to. So this is the maximum peak at the negative, and this is the maximum peak at the positive conditions, that is in the positive side. So altogether the again the second half cycle will be again another 10 milliseconds, so totally 20 milliseconds. This is for a 50 hertz supply. So I say it as frequency as 50 hertz supply. So when I find the time period, it's 1 divided by f, which is 1 by 50, which gives you 20 milliseconds. So out of 20 milliseconds, first half cycle the current will be in one direction, that is from A to B, and the second half cycle the current will be traveling in the other direction, opposite direction. So there is an alternating of current directions. So this is why the current AC circuits are called as the currents are in bidirectional condition. But In the same way, if the same conductor is kept provided and the it is connected to a DC supply like batteries, the current direction will be in only one direction, which is IAB. It will not come. It will not return in the same line. So that is the current will not reverse. So it is a direct current. So now we should think that if I am given with an AC current or AC supply, we can introduce these diodes. We can introduce these diodes as a component to convert this AC to a DC, because when a supply of AC is applied to this diode, the diode only allows the current to travel in one direction. In that case, I would assume that if the current by the diode is allowed only in this first half cycle, only in this first half cycle, the second half cycle will not be allowed to carry. So until the full operation, in every full cycle only the one half of the cycle can be converted, the other, that is the reverse current, will not be converted. So altogether if you accumulate and see, all the waveform which is formed at the finally will be present in the positive direction, and whatever the waveform in the input which was in the negative side will not appear in the output. That means on the output you will could see only the waveform appearing in only one direction, which is the positive side. So eventually I can say that my diode is able to convert the bidirectional current to a unidirectional current. So this is how it started. So in this application we would, the further application what we see is here rectifiers. So rectifiers are a circuit which converts the fixed AC supply to a fixed DC supply, and fixed AC to a fixed DC. So when you put a rectifier in an AC circuit, the output what you get is a DC. So that is called as a rectifier. And in this rectifier we would have many types. So one is the half wave rectifier, the other one is a full wave rectifier, and the third one is the full bridge rectifier. So we will see in depth about how the half wave is constructed, full wave is constructed, and the bridge rectifier is constructed. Right, coming to the half wave rectifier. So in half wave rectifier, I'm by the name we say we are going to convert, or we are going to rectify only the half wave of the input to a DC supply. So eventually I could say like if I have been given with an input supply which is an AC supply, let me take it as a AC single phase AC supply of 50 hertz supply, and I have a load here which I am considering to be a resistive in nature, so it's a resistive load. I mark it as RL. I want this load to be always operate in a DC supply, but I am given with an AC supply. So what we do is, let me understand in this way, the load has two terminals A and B. So if I say this load RL to be DC, I should always understood the current direction one should be one direction. So I assume to be the current direction is always from A to B, whatever the input is. So in that case, what I do is, first I connect this circuit, that is from input high terminal. I consider this as a higher terminal, so I'll mark it in this way. Now I consider this as the higher terminal and this as a lower terminal is neutral. So what I do is I connect this, I put my diode such that the higher terminal is connected to the anode and the lower terminal is connected to the cathode. So this is actually the anode and this is actually the cathode. So what happens in the first half cycle, that is my input is an AC. So I'm going to draw the AC input waveform. The first half cycle, the waveform will actually look like this, the positive half cycle. So the current starts to move. I can understand my anode is in positive, connected to the higher terminal, so the current can move. So the current travels. This current passes through the diode because it conducts, because it is forward biased, and it travels through this point, goes in this direction, passes through A to B, then it returns back. This happens the first half cycle, which is the first 10 milliseconds. So I can measure my output. I'm measuring my output voltage. I could see this, since the output is uptime, that is from the output is seen, the current is able to flow through the load. I could see the output waveform is also similar to the input. The second half cycle, I would consider my there is a change in the terminals in the input side, because in the next half cycle, the this becomes the phase and this becomes the neutral. In the second half cycle, what happens is, the in this type of connection, the cathode is now being connected to the higher terminal and anode is connected to the lower terminal, so it becomes a reverse biased. So in reverse bias, we know that diode acts as an open circuit. The current cannot flow through it, so therefore the output does not appear in the load. So the overall circuit, that is in the second half cycle, the AC input will be there, but the output DC will not be there, it will become zero. This again repeats. Make sure that the next half cycle, that is the next cycle's first half cycle, will be, the input will be like this and so on, goes in this way. So from this input waveform, we can see all the input which are appears is always in the one direction, positive direction. The current is in the same direction, so eventually it is converted to DC. So we are able to, like, if suppose if you give your input some value like is V in, the output value will also be V naught, will be equal to V in. That is, the major advantage in this operation is the output voltage magnitude is same as the input voltage magnitude, but the major disadvantage is only one half is rectified. So it becomes a pulsating, it kind of becomes a pulsating uh, pulsating DC, which is discontinuous, and we don't have the one half of the cycle, we don't have the output. So it means that if any object is connected, or if any electrical appliance is connected to it, that electrical appliance will get the input only 10 milliseconds out of every 20 milliseconds. So that could affect the life of the application. So in this case, we would prefer to jump to another circuit where we are could able to overcome this disadvantage of making the circuit to conduct in both, in the both cycles they are to convert. So what they do is they go for the next one, which is called as full wave rectifier. That is going to, we are going to rectify full wave. We are going to rectify all the full wave. Okay. So in the full wave rectifier, we understood that we understand that we have an input supply, okay, and we are given with the same load. I'm taking the same circuit. So I wanted to appear it for the same duration, that is both the half cycle, and I have to convert it. So what I'm doing is, I'm going to use a transformer in this case, where it is a center tap transformer, because I want to apply two diodes, which can be applied in both the input and output directions. So I'm going to put a transformer in it. So the transformer is connected, so you have the primary side of the transformer and the secondary side of the transformer is this, and it is a center tapped. We have a provision, that is we have 3 connections output in the secondary side, the center tap transformer. What I am going to do is, I have been given with the load, let me connect it to the center tap of it, and now I will connect the one diode in this direction, the other diode is in the same direction as before, disconnected like this. The very well understanding of this circuit is, during the positive half cycle, this terminal will be positive, that is in the phase, and this n term will be the neutral. And during the second half cycle, so let me see now, let me tell you how the current travels. So in the positive half cycle, so I'll take the input as something like this, positive half cycle, it travels in the positive half cycle. The current here, because this is positive, the anode is also kept positive and cathode is kept in a lower terminal, so the current direction goes and it is in this direction. Now let us assume this point is A and this point is B. In the negative half cycle, the things change, like this becomes a positive, this remains the neutral, that is this is the phase and this is the neutral. So now the second diode can activate, and then that is in the second half cycle. So the output, if I have to mark before, you could see my output voltage waveform. During the first half cycle I got my output, right, and in the second half cycle now the current is going to travel in this direction because this diode is activated here, and again you can see the current through the load is in the same direction, again is from A to B. So what is the same, since it is the same direction, it could cover up this area, that is in the second half cycle it is also being converted. So this is first 10 milliseconds, this is the next 10 milliseconds, this is, we call this our output voltage, and this is me input voltage. So altogether the main advantage of this circuit is I was able to convert all cycles to DC. But here again the main disadvantage is, during the first half cycle I could see only the out of this secondary, half of the secondary is being utilized. Suppose you say my secondary actual input is something V in secondary, here only V in by 2 is utilized, and the second half cycle again the rest of other V in by 2 is utilized. So altogether this supply, that is this the load, always gets a voltage which is half of the input. So the output that I measure here is nothing but output voltage is less than, or I could say is half of the input voltage, So in the last case we were able to overcome the advantage of converting both half cycle to be rectified, but the problem is the problem is like only half of the output, just half of the input is converted to an output. So this is half wave, this is, sorry, full wave rectifier, but it is used to a center tap, so we can name it as center tapped. It's a center tap connection. So now now we have to consider both this advantage, this one and this one, that is I need a circuit which will convert both the half cycle to a DC, and the same time the output will always have the same as that of an input value, that is, it will not be lowered. So in that case, we will jump to another circuit called as bridge rectifier. So bridge rectifier is an interesting topic. It's almost used in many applications where they convert an AC to a DC every half cycle, and the output voltage will be as same as the input voltage that is appearing. So both the advantage and will be occupied and the disadvantages will be omitted. So here, to understand that, I have a I have a input supply. Okay, here I have been given with the load, a resistive load, which is considered to be a DC load. So I would always remember that my current in this DC load should be always from one direction, which is A to B. So what I do is, now I would have a graphical representation of the input, and the output graph I'm drawing it somewhere here. Okay, so let me connect this circuit. So I want that current, that is the current, to flow from my source to my load side. So what I do is, I put a path, I give a path to that circuit, putting this diode connected to this. Let this diode be D1, and in the return path there should be another path to return, so I put another diode to return to it in this direction. So this is D2. So in the positive half cycle, when it starts to conduct, input is applied, so this becomes phase and this becomes neutral. So the current, you can understand that the diode D1 anode is connected to the positive, that is, sorry, the phase of that is higher potential, and the cathode is connected to the uh, neutral side. And similarly for the diode D2, this anode is connected again to the phase, and this cathode is connected to the neutral. So both are forward biased. We can say this is also forward biased and this is also forward biased. So since it is forward biased, we could see the current can go here, go through the load, then returns back to the source through D2. So the current is applied and the full voltage is applied here. So that's why the output voltage can draw the full voltage being converted in the first half cycle. So in the second half cycle, as you know, this becomes the phase and this side becomes the neutral. Eventually it changes. Now in this circuit, now we can see that there is no path, because since D1 and D2 are reverse biased, right? It is reverse biased here and is also reversed bias here. So in that case it cannot conduct, but my ultimate solution is to make sure that make sure that it also conducts in the second half cycle. So what I do is, I create a path. So I take a branch from here, put a diode, and I give it to this point. So in the second half cycle, this you can see this, and for diode, which is the diode is D3 here, which has an anode here and a cathode here. You can see the anode getting connected to the phase of the second half cycle, and this cathode is getting connected to the should be connected to the, and so I bring the return path somewhere. I take a branch here again and I connect it across like this. So what happened, this is D4. You could see this anode is again connected to the face of this circuit, and this cathode is connected to the negative part of that is the return path or neutral path of it. So the current that now can travel in this direction towards this travels to D3, gets back, again the current is traveling in the direction of A to B, so the current direction is not changed. You can still see that the output voltage is again during the half cycle is again same as the input, sorry, but it is in the current, since the current direction is not changed, it will appear in the positive side itself, and it comes return back here, goes here, D4 activates. So D4 is forward biased, D3 is also forward biased, and it goes this way and then falls to the return path. And you can still see that the D4 and D3 will be reverse biased in the first half cycle. So it means in the first half cycle the D1 and D2 will operate, and in the second half cycle D3 and D4 will operate. So from this circuit we can very well say that a bridge rectifier consists of 4 diodes. 2 diodes operate during the first half cycle and the other 2 operates in the second half cycle, right? So now the both the advantages, that is, we can note it here, this bridge circuit is able to convert both half cycles to DC, and output voltage magnitude is same as that of an input voltage magnitude. Okay, so these are the differentially in the difference form we can able to study the half wave rectifier, full wave rectifier, and the bridge rectifiers. So this is the way basic understanding of the circuits that will be helpful for you for understanding further, right? Thank you.